In the last video, I talked about how when you look at the spectrum of light from hydrogen in a discharge tube with electric current going through it, which causes the hydrogen to glow. When you look at the spectrum of this light using a diffraction grating, you would see 4 lines, right? Red, cyan, blue, and maybe violet or indigo. You'll see these 4 lines. Now this kind of a spectrum, which contains lines instead of a continuous spectrum like the rainbow, it's called a line spectrum. And let me just add a word to this name. I call it a line spectrum. Just to distinguish it from what I'm going to talk about in a moment, this kind of a line spectrum is called an emission line spectrum. Emission as in light is given out from the source, from this, and the light given out from the substance like hydrogen gives the spectrum directly. But that seems rather obvious, but in a moment you'll see why we need to add this word, emission. Now let's go back to the sun and this continuous spectrum. And what I'm going to do is this. And what I'm going to do now is this. I'm going to put this hydrogen discharge tube in between the sun and the hole. Okay, so let's see how much. Let me draw this. Right, this is what I'm going to do. Let's say I have the sun outside the window. It's a very, very bright and sunny day. Now, this is my window. I have to put a blind over the window and maybe with a hole in it. Okay, so the sunlight would come through this little hole, and now in front of this hole I would put this discharge tube. So I'm going to put this hydrogen discharge tube here in the way of the light. Okay, so that's hydrogen, and then there is the negative and positive pole connected to a very high voltage, and that would give that would cause a current to flow through the hydrogen gas, and therefore make it glow. So this tube would give out lights, as we have seen previously. Now we are going to allow the sunlight through the hole. We are going to allow this ray to go through the discharge tube and go through maybe another hole, and then be split by, okay, I should use a grating. I should use a grating instead of the prism. So let me take away the prism. Right, I want to replace this by a grating. Okay, so let's say the sun's ray comes through here and splits into the color of the rainbow. Right, now the sunlight, okay, the sunlight would be very bright. So we are going to assume that we're going to set this up. Actually, we don't have to assume. We're just going to set this up so that the light from the hydrogen is dimmer than the sunlight. So the sunlight will be a lot brighter. Right. So when the sunlight goes through it, most of the light here would still be the sun's light, plus a little bit from the discharge tube. Okay, it's sort of these four colors of light. And when it comes through, right, the light would together be split into the prism, and we would mainly see the usual spectrum of the rainbow from the sunlight. Now, but then we also see something else, right? With the hydrogen discharge tube switched on in the path of the sunlight, we would see something else. This is what we would see. We will see a line about here. We will see a line. We will see a. Wait. We need to draw this through the whole thing. So we would see a line here. We will see a line about there. We will see a line there, and we will see a line there. Redraw this a little bit. Here, here, and here. They're supposed to be very straight and very sharp. Okay. So we'll see four dark lines. Okay. Now I should emphasize at this point that if you look very carefully, those lines will not be completely black, as in completely no light. There will be some light. There will be some light coming from the glow down here. Okay, the light from here would be here, actually, but it will still appear dark. It will look black because the sunlight that produces this other colors is so much brighter. Okay, but there would be some light here. Now we'll try to understand why in a moment. But first, let me point out that the positions or the wavelengths corresponding to these lines, if you like, these missing lines, because they are dark, that means no light or very little light. So in a sense, they are missing wavelengths. They're like missing wavelengths, and the wavelength corresponding to this missing wavelength is exactly the same as the wavelength of the lines that you would see on the emission line spectrum. Exactly the same values of wavelength. So in other words, it's as if the colors, the bright, thin, sharp lines that you would see on the emission line spectrum of hydrogen gas, it's as if when you set it up this way, these bright lines gets inverted and become all black against a colorful background of the rainbow color. So what's going on here? Okay. Well, right, let's try to understand what's going on. Actually, we won't be able to fully understand what's going on until we learn about atoms in the next few videos. But what we can say at this stage is that when the sunlight goes through this discharge tube, the wavelengths that correspond to these on the emission line spectrum somehow gets absorbed by the hydrogen gas. Okay, it gets absorbed. Now, of course, the hydrogen gas can't just keep absorbing these lights and don't give it out. Right? Otherwise, it would just gain more and more energy and get hotter and hotter. What it would do is it would absorb those lights corresponding to these wavelengths, these 4 wavelengths, from the ray of sunlight that goes through it. It would absorb those wavelengths and it would re-emit those wavelengths. Right? As it absorbs, it has to give it out again. So it re-emit in all directions. It re-emit in all directions, so that it's like it spreads out the energy of those wavelengths all around, so that the wavelengths that are re-emitted, alright, so that those part that happens to continue in the same direction would just be a tiny fraction of those that are re-emitted. So that's why we get dark lines here. And so actually, these dark lines, they will still contain some of those wavelengths that were absorbed and re-emitted. But it's just that only a small fraction of those would continue along the same direction. The rest would go in all other different directions. Okay, so at least this understanding helps us to understand why there are these dark lines, but it doesn't really explain why the hydrogen gas would absorb those lines. Okay, so let me finish off by coming back to say why we need to add the word emission in front of the name for the line spectrum in this case. The reason is quite simple. It's because we are now looking at what looks like the reverse or the inverse of this emission line spectrum. Instead of bright colored lines on a dark background, we have dark lines on a colored background. Right? We have like what looks like an inverted image. And this happens, as we kind of understand, because those wavelengths corresponding to the emission spectrum, they get absorbed by the hydrogen. Alright, so we need a name for this spectrum because it's obviously different from this. And the name of this spectrum is called absorption. You have guessed this, absorption line spectrum. So you see, there are 2 types of line spectrum that there is emission line spectrum and there is absorption line spectrum. So that's why we need the word emission and absorption in front of the line spectrum to distinguish between them.